Anything else, please let me know. And if you have a question, raise your hand. I think I can unmute and we can address the questions right away. So a little bit about myself. I have been in the software space about for over 25 years. Right now, my current role is CIO and Chief AI Officer at a federal space. So I'll get started on the backend development and deployment. The deployment I did not cover that much, but I think at least for the hackathon perspective, the development is more important than deployment because deployment comes later when when you're growing and having that growing pains. So okay, so I want to touch on some of the key ideas in backend development first. There are some concepts that you have to know before you uh, try to do the backend development. So I'm going to go through that one. And the first thing you probably have to know is stateless architecture. Um, is there any way you guys can give me a thumbs up if you know what is a stateless architecture means? Uh, okay, people are streaming in. So stateless architecture means is where a server that is like does not store any information for your client. So there could be thousands of servers, and each of the servers does not store any information. Like, for example, and any information about the client is called a state. That's why we are calling it the stateless architecture. So let's say, for example, you have a shopping cart in your application. Now, traditionally, what you see in the industry is when you log in, you add something in the cart, and then you get out, and then you come back in, it's still there, right? But what happens in the back is that the server that was servicing your request is not the same one. It's probably you were connected to a different one. So the reason for that, why the stateless architecture is important is you don't have to worry about the traffic or how many users that are coming in, because if your server is stateless, you can have one server for like 5 users, and then as you grow you can add 50, and then if you go to millions I can add hundreds and thousands of servers, and each of the servers does not store anything about the information. I don't have to prime it, like for example populate it with some information, or else that will become a big bottleneck. So all of that state that the user needs is all stored in a database. So the server comes up, and then it tries to grab whatever it can, what it needs from the database, and then it uses that to process your request. So I'll pause here. If you have any questions, let me know. And this is one of the key concepts. I think it previously it was where one server would have everything in it, and it was very challenging to scale, especially. So all right. And then the next key concepts in backend development you need to be aware is APIs. So API is you can think of it as a contract between two people, or two systems here, two machines, where and there is a server that is saying, what, I'm going to provide you a service, and this is the way you can call my service, and here is the data I'm expecting, and this is the return value that I'm going to give it back to you. So the API will give you all of that. So one of the most popular API that I can think of, probably the oldest one, is your Windows operating system programming API. So in the Windows programming world, you use Microsoft's Windows API, and you look at the documentation and you basically say, oh, this is what I need to pass as the information to call this API so that the operating system can give me the service. Like, for example, your desktop application might need an access to your microphone. So you don't directly go to microphone here because you don't want to deal with any kind of device drivers and different models and things like that. The Windows API takes care of that for you. All you have to do is call the Windows API, and then you get access to the microphone. It doesn't matter what model it is, right? So that's how the APIs work, because it gives you a nice abstraction, and then you know what to expect and what is the error code and things like that. Now, as the technology moved on, we need a different kind of APIs. One of the most popular APIs that you see is the web APIs. And there is a new one called even Graph APIs, which is a little bit more specific or serves a different design paradigm than the web APIs. Okay, and then we are moving on to RESTful APIs. Now, what is a RESTful API? It is a special kind of API that you would use in the web world. In the world of internet, the RESTful API is the one that how all your not only your computers, your phones, even your things at home, the fridge, your thermostat, even your IoTs. If you all look at it, if you watch the traffic, they are all talking to a server, and they are using REST API. And and the REST API and the stateless architecture go together very nicely, because one of the principles of the REST is the client takes care of all the state. It takes care of the state, and then it comes to the server, says, hey, here is what I have about the information about the client, and here is his ID, and this is the shopping cart ID that I have that I need to access. And then you give it to the server, and the server, if you look at the previous slide, we have something called stateless architecture. It says, okay, I'm going to take what you give and I'll verify, and then I'll go to my database and then get you what you want. So, and then the REST APIs, they made something very popular where now you're not talking as a servers anymore. You're talking something called resources. So I need a resource that's running out in the cloud or in the internet, and you don't have to worry about what kind of configuration that server has. Anything. All you need is, I'm looking for a resource called students, because maybe you're building some kind of an education app. And then in the REST API world, the way you interact with the students is using a HTTP method, right? You have an HTTP protocol, and in HTTP protocol, it gives you only 4 methods. Like, you can post, you can get and put and delete. And then what the REST API did was it took that HTTP methods of post, get, put, and delete, it mapped to an operation on your resource. For example, a post will create a student, because you are basically posting a form of the student information that's there, like a name, address, parents' name, email, and everything. And then when you do a get, you get the student information. Now, if you want to modify a student, then you would use a put method, and then you would give the whole information. Remember, the state is coming from the client now. And then the server says, okay, I'll take the student, all the information. I'm going to check the database, make sure it matches up, and then I'm going to update the student. And then finally, we have the delete. And usually the delete and post, if you look at it, the web and the browser will treat it very differently, because it won't let you constantly send it. It uses some kind of a form method, and that is there for your own protection. I don't know if it happened many years ago, like when there was a search engine optimization was pretty popular over 10 years ago, a lot of the people had delete marked as a GET request. So when the Google started crawling all the websites, it started clicking and it started clicking anything like, even the delete function. And a lot of people lost their data. And because of browsers, when you have the crawlers that are like crawling the web, the only method that they do is get, because that's how they are interested in getting the information, so that they grab all the information that's on the web. They don't create anything or delete anything or put anything, so they never do that. So what happens is you're basically saying that, oh, click on me to delete, and then you're servicing with a GET request. Guess what happens? The robot that is crawling your web is going to click on that link thinking it's a GET request, but you did not mark that delete function to a delete HTTP call. Instead, you marked it as a GET request, then it ends up deleting your database. So you have to be very careful how you delete how you design your REST APIs. If you want a consistent experience, anytime that you're modifying something in the backend, then you would always use the post and the put and the delete methods. Anytime that you are just doing a read method or just returning information, you would mark it as a GET request. So that's how the REST APIs work. So just to summarize, we covered three important key ideas in backend development. One is the stateless architecture, and second one is the APIs, and then the third one is the RESTful APIs. Now we are going to go look at the backend architecture itself. So now what makes up a backend architecture? So typically a backend architecture is made up of these components. Typically you have a server, and then the servers are talking to the clients using an API. And then there is typically a database where you store all the data. In addition to that, you could have a caching layer and some authentication and middleware. These are pretty advanced concepts, so I'm not going to talk about them. But think of it as, if you're running a very popular service or a shopping and everything, and lots of people are coming, what happens is if you can't be accessing the database over and over again, because then your users will start seeing the delays. So you would build up the caching layer. And then briefly touch upon authentication is, right now, people don't like storing their username and password. They just want to use their Google login or Instagram or Facebook login. So you need to provide a authentication layer using the social logins. And then there's a middleware where you want to fire certain events in the backend, like when somebody places an order. What do? You can use your middleware to trigger an event. Okay, now the customer has ordered. Let me do some check the inventory and start processing the order, send an order email, and all those things. You can do it with events and everything. So, but the key component being, you have the servers, API, and the database. So we're going to focus on one of them each. All right. So you have the servers and APIs. Now, typically, like, maybe 15 years ago, we used to have, actual servers on racks, and then we would choose a certain memory and a hardware, and make sure it has a nice bandwidth and everything. Now that those are all gone now. Like, people typically who develop software typically don't deal with servers. They just rather go with something called containers or lambdas. Now you have it. Now, basically what you have done is you've collapsed your server and APIs. Those things got abstracted into containers and lambdas. So what is a container? Container is where it's actually like, an abstraction where it has all the necessary software that powers your API. It basically knows how to process your REST API request, and then it goes to a database. It has a database driver to get the data, and those are the only pieces it has. It's a very uh, has a very small footprint. It has only the software it needs, and then it comes in a container abstraction. And then you take that. Typically, when you're developing, you will use a Docker desktop. When you're ready, you would go to a container service. In Amazon, there is a Elastic Container Service, and then you would just host it there. And then what Amazon is telling you is, okay, you give me a container, I will just scale it as the traffic comes in. So for you, you don't have to worry about your servers, and it's also cheaper for you because you are in the pay as you go model. Like, you pay only when Amazon says, okay, I have one container that services 10 users. If there are more, I'm going to spin up one more container. Then that way, you're just paying for the one container that you have, and it's cheaper for you. Typically, right in this current environment, I have been developed some applications with React in the front end and the Lambda and Dynamo database. Typically, that infrastructure with AWS pieces can support million users very easily. I don't have to do anything because Amazon takes care of the whole thing. I just provide my functions, my APIs, and my database, and then I do some optimizations, and then it's ready to go on day one to support a million users easily. So, but at the end of the day, if you want to know how much it costs like $1 or $2 at the end of the day, because there is nobody there using it. But when it grows, even when it grows to thousands and thousands of users, I only pay when it gets used. Probably my bill will go to like $20, $30, not much. So there is a very low barrier right now to build what you want on the day one that's ready to go for millions of users. You don't have to do much, take care of certain things, and then you're good to go. Day one to service 10 users. Next day, you can ready to service million users and for very less amount of money. And then there is another concept, as I briefly touched upon, Lambda. Lambda is, if you look at it, instead of container, you're just saying, here is my function. Like, for example, let's say you are writing a Lambda function, you have an API that adds two numbers. I know it's silly, like, the user says, here is my two numbers, and you have a REST API that adds two numbers, and then your Lambda function, it's basically just that. It takes two numbers, adds it, and returns it. So think of it as that is your whole backend. That, your adding function is your whole backend, and that is one function. And then if you want to do subtraction, multiplication, you add more functions to it. If you think about it, you are not worried about servers, you're not worried about CPU, you're not worried about hardware. You are just writing functions that will just execute whenever the user wants it. And typically, both the services, containers and Lambdas, they typically have RESTful APIs because that is the language of the web. If you have users, you will pretty much, the first thing they will ask you is, oh, you are providing this service. Okay, now you have your own UI. Can I also use your API? Because I don't want to use your UI. I have another use case where I want to directly talk to your service. So that's where the APIs come in as well without the UI. So, okay. Now we move on to the databases. So databases are critical in stateless architecture because they are your the one asset that I would probably be really careful about taking care is your databases. Because once your databases grows, that is your what do you call that, critical business infrastructure. Lambdas, they can just come and go, they can get destroyed, but databases, you don't want to lose them, right? So you always want to protect them. And then two popular ways of serving up your data is relational and NoSQL. And if you're familiar with relational, these are your regular uh, databases that are Microsoft SQL Server, Oracle, MySQL, Postgres, you name it. There are many, many different flavors of relational database, and each one of them have strengths and weaknesses. But at least for beginners, you don't have to worry about them because you are just worrying about, okay, how do I store my data? How do I get it? How do I have my REST API talk to it? But once you scale up to, you know, thousands and thousands of users, then each database will have a few quirks, like, how to make it run faster. How do I, get all the data in bulk? How do I update only a certain part of the database and not worry about the rest of them? And typically, if you go to the relation database, you have entities, and then in your entities, you have many tables, and tables are connected with foreign keys, and then you have a API layer that knows how to take the whole table out. Like, for example, you have a student table, and then one row in your database will be the whole student information. And then if the student has enrolled in a certain classes, what you would do is you would take the student ID and you go into the enrollments table, and you grab all the classes they are enrolled in. And from there, you can go to the classes table to get all the classes about the details of the classes. So, it's like a big grid, and sometimes it can get very overwhelming. And because when it comes to building a software, typically what people do is they spend some time to, what do you call that, design their databases. Because what happens is once you design the database, it gets a little bit harder to change them. So the industry saw that was becoming a problem. They started looking for an alternative, and that's why the NoSQL came. In NoSQL, you just worry about the entity, like student. Now, in NoSQL world, you don't have to worry about students, enrollments, and classes. Rather, you can just get started with students and you put everything in there, like enrollments, classes in like one table with everything in it. And then you have a JSON format to return and interact. And this is a very popular way of getting started, like, because you don't have to worry about it, and you can just like put in any kind of data that you want. And then you can, as you grow, then you can start, like, optimizing certain fields that are, or columns that you need, and from there you can get a better understanding as the most users come on. Now, in both of these kind of databases, there is a point where you might hit some uh, scaling issue where they are getting slow as more rows are added. And so in that, what you need to do is you have to add some indexes. Indexes are special things where they allow for a fast retrieval of data. And in NoSQL world, there is a different way of dealing with it called, they do use called something called sharding. Like, for example, I can shard the students based on their names. Like, for example, if the last name is starts with an A, I can go to the A shard and get the data because I know it's not going to be in any other this thing. So that creates its own complexities. But either way, at the end of the day, you need some kind of indexes so that you can retrieve the data in a fast fashion. So now we covered servers, APIs, and databases. Now the technology has progressed even more, where the users are saying, I don't want to deal any of that. Just give me a backend. You know what? Why do you need a backend? You need a backend to store your users' data, because when they come back, or and you need a place where you can retrieve the data and then you can talk to the user. So backend as a service is an encapsulation abstraction where you don't even have to deal with containers, lambdas, anything. You just get a service that you call, and that's how you deal with your backend. Now, the backend combines APIs and databases. In addition, what is the advantage of a backend as a service? They provide authentication as well. Like, I don't have to go worry about how do I set up a Google login or an Instagram login? You get everything in a backend as a service. You can just with a few clicks, you have everything, you are ready to go. And then they also give you they automatically once you put in your database schema, they'll automatically create the REST API for you. They'll have some addition of functions where you can execute certain reports and logs and things like that. That way you get one single package and you don't have to worry about, how much servers do I need and things like that. So what are the popular backend as a service providers? There are quite a few right now. There was used to be a very popular one called Firebase by Google, and it's still there. But I think you have to, it's a configuration I saw, it was a little bit not easy. And then there is a very popular one called Supabase, which is based on Postgres. It's basically you develop locally with your Postgres database, and then once you're ready, you can upload it to Supabase, and then there you have it. It automatically creates the APIs for you. It stores the data for you. And there is one caveat where your Supabase is Supabase uses a concept of private and public keys. And that's the way that you keep your data safe, and that's how you access it. And typically, your application is running in a web browser, right, in a JavaScript using React, Angular, or uh, any kind of a popular front-end library, then it will call Supabase. You have to be careful not to expose your private key, because if you do that, then anybody can take over your database and insert and do all sort of things. And then there is a very popular called Pocketbase.io. That is a very popular backend as a service. And then there's a company that also provides content delivery networks called Cloudflare. They have a concept of cloud workers. Cloud workers and functions are sort of the same thing. And they also have a database, I believe, called D1. So you can combine that. So you get your whole backend in the cloud. And what you typically do is they give you a software development kit. They'll say, okay, what is your front end? If your front end is React Native, which you use for developing Android or iOS application, they'll give you an SDK. You take that, and there you go. You can access Supabase, Pocketbase, and Cloudflare. And then if you're using React Web, you can use that SDK for that. And then you can directly use the service as well. So there are many options. So right now, for hackathon purposes, I think I would definitely recommend backend as a service that will really accelerate your development, and that is a very popular way of doing things right now. So, and then that's the end of the slide. I am happy to take some questions. This was just a very basic introduction. So if you have any questions, please raise your hand. I can unmute and then we can address your questions. Okay, I'm going to stop sharing. Just want to see if there's anything on the chat. Any questions? All right. I hope this was helpful, and I hope you have a good hackathon, everybody. Thank you.
So, Jazakallah khair, Shakir. So, this tool is free, or they have to subscribe?
They typically have a free tier.
Okay.
Especially Supabase is pretty popular, actually. And they always have a free tier which you can sign up and get.
Okay. So how does it tie to the other programs, other workshops that we had, like a couple of workshops we had? I don't know you had a chance to see those things or not, but how do we tie those? Like, for example, one of those was that agent, what is that?
Agentic AI, I didn't see that. I saw one by Brother Zaman.
Zaman, how
And
does
yeah,
that?
so if you look at it, he used the tool called Lovable, right?
Right.
And if you looked at that Lovable, it uses Supabase automatically. It for Lovable, when the AI generates a code, it automatically assumes it's going to use Supabase as a backend as a service. So you have to have an account in Supabase to run it. And usually they have some free credits. Pretty much everybody has some kind of a free tier for you to run it.
So if you go through the Lovable, then it does automatically connect, or you have to still subscribe?
No. Lovable just will give you the code,
Right.
and it will automatically assume that you're going to use that service, the Supabase service. And then in that code that it generates, it will have a place, put in your Supabase key, and then the application will work. So you have to add in some configuration there, right? Like, your credentials, your account number, your key for those services, and then they work.
For the free account, how many tokens, or how does the token are used? Is that very token extensive? Like,
It's usually there is a free tier. I'm not familiar, actually. I don't want to give wrong information, but even if you exceed, it's only like a few dollars, I think. And I think this is a good point, though. All of them offer a free month on their service. So it's like there is a trial period for you to try their service where you don't have to pay. So trial period would be a good advantage thing to take advantage if you have to do something for that.
now, would the student be able to use this service with the short notice, like on tomorrow if they start and
Yeah,
subscribe?
of course. Yeah, it's typically ready within so you just go there and you sign up, it's there. It's like instantaneous. There is no waiting period at all.
Okay.
Yeah. I mean, if there's a waiting period, they won't be in business at all because nobody wants to wait.
Right. And I don't use this. That's I wanted to make sure that. So the link they can search the Google and find the links, or
Yes.
you have. Okay.
I can share the links in the WhatsApp chat later.
That would be good, inshallah. If any information that you feel like
Inshallah. Okay.
that it can be useful, that would be great, inshallah. So I don't know, anybody has any questions?